Okay, in this video episode, I'm going to show you how to do a horizontal translation for the function of y equals the square root of x. And the translation is going to be horizontal to y equals x minus 3. We know it's going to be horizontal because it's a square root. The function is everything inside. It's as if we got brackets, and whatever happens in there is going to be a horizontal dilation. Now, if I had the minus 3 outside the square root sign, then it will be a vertical. But it's inside the function, that's a minus 3. Notice that it's a minus 3, it's going to have the opposite direction. For example, if we have a negative inside brackets or inside the function, as we do here, a negative means we're going to be moving to the right. And the opposite again, if it's a positive, we're moving to the left. So that's not a positive, it's a negative, so we're definitely moving to the right. So let me just mark that up. So we're going to move to the right. We're going to shift to the right 3 units. But first, in order for that to happen, we need to actually draw the parent function, which is y to the square root of x. Now, in order for us to do that, we're going to use a table of values. Once we install those values, we can plot them up here on the number plane. And then once we identify the points on that curve, then that function, we can start to translate it or shift it across 3 units horizontally to the right, whilst maintaining the same shape and size. Okay, so let's begin with the table of values. So we're going to have the values from, let's say we'll go from -1. So we're going to have x and y. And let's have these points here. And we're going to have the values will go from -1, 0, 1, 2, 3, maybe we can jump 4, and maybe we'll jump to a 6. Okay, let's take these values and substitute them straight into the parent function right here. Y equals the square root of x. So let's do that. Y equals the square root of -1. Is it possible? No, the calculator is going to say error, so we can't go there. So that's not available. Let's put the square root of 0. Well, that's 0. The square root of 1 is 1. Square root of 2 is 1.4 approximately. The square root of 3 on your calculator, that should be about 1.7. 1.7. The square root of 4 is 2. And the square root of 6, that's going to be about 2.5, I think. 2.5. Okay, so let's take these points and plot them up here. So the first point, -1, doesn't exist, so we got 0, 0. So we're right at the origin right there. So there's our first point. Then we go to 1, 1. So it goes right there. Then we go to 1.4. 2, 1.4, that's about there. Then we have 3, 1.7. 3, 1.7, that's about there. Then we have 4, 2. 4, 2 right there. And finally 6, 2.5. We jump into 6, 2.5 right there, 2.5. Let's join the dots. So that's our curve there. Y equals the square root of x. Okay, the next thing we want to do now that we have that curve, we've established it, we're going to use the technology of translations, where we're going to shift and slide horizontally along the x-axis. We're going to move it how many units? 3 units to the right. So let's mark out 3 units to the right. So 3 units to the right, I'm going to count from this point, the origin. We're going to go horizontally 3. 1, 2, 3. So that's our new origin right there. Then I'll take this point, 1, 2, 3. That's going to go there. Then I'll just pick this one, 1, 2, 3. That's going to go there. And this one, 1, 2, 3. Keeping on the same plane, same height. So we're transferring them exactly over. I didn't take all the points, but most of them I did. 1, 2, 3. So I could go about there for this one. That one there, and this one here. 3 points, yeah. So now all I have to do is just join all the dots. So there it is. That is y equals the square root of x minus 3. And remember, minus means we move to the right. So this exact shape and size has not changed in any way. It's just been shifted, and we just slide it 3 units to the right, and we form the new equation, new function, y equals the square root of x minus 3.